Okay. So as I was saying in the beginning, this is about naming, uh, and this one is the first 10 exercises are only for covalent. How do I know they are covalent compounds? I'm gonna write the name. Sorry. How do I know they are covalent? You just have to take a look at the elements. Okay. Take a look. You have sulfur and you have nitrogen. In the periodic table, the two of them are located in the non-metals part. Okay, if they are non-metals, means that is going to be a covalent compound. That is the first thing you have to see. And then what you have to consider is the prefixes. Okay, remember that I gave you prefixes. I think I have it here. I have the list of prefixes ready, handy for us to see to what prefix it corresponds. Entonces, let's begin with the first one. You see that you have to take a look at the amount. You have to take a look at the amount of atoms. Okay, atoms are the subscripts because it is 4. You have to take a look to the table, okay, and see that the number 4 corresponds to the prefix tetra. You know, like like Olympia, the only tetracampeon from Honduras. Okay, like that. Tetra means 4. Okay, so tetra is going to replace the number of atoms. So this compound is made of 4 sulfurs and 4 nitrogens. So the rule says that the first element is written completely, okay? But the second element, because it's binary, only 2 elements, it will end in IDE. So, tetra, and then write the name of the first element, that is sulfur. And then the other atom. The other atom is 4, so again we have another tetra. Then we write the root of the second element. Remember that I gave you the special roots. I gave you special roots. Let me see. Okay. I need them over there. So all these tables that I use, you must use them, okay? It's very useful that you keep them with you. So take a look. I'm not gonna do them all, okay? I'm just gonna do like 3 from each bunch of exercises. You will complete the rest. And if you want, I can provide you a website so you can practice this topic. Okay? So, the second element is nitrogen. So we're going to see the special roots for nitrogen. And as you can see, the special root for nitrogen is nitr. Nitr. Okay? So it is tetra nitr. And then the suffix mandatory for this kind of exercises will be IDE. Like that. Tetrasulfur, tetranitride. Now, if we follow the same principle for the second exercise, carbon. You see carbon over there doesn't have a prefix. So, if it doesn't have a prefix, what number is that? How many atoms are those?
1.
Exactly. 1. When you don't see a prefix, the prefix will be 1, okay? So, in this case, carbon will have only 1 as an atom, and chlorine, that is the other element, the prefix will be tetra, and tetra corresponds to the number 4, okay? Chloride refers to the element chlorine, okay? So the formula for this one is made of 1 carbon and 4 chlorines. So the formula will be carbon with no substrate, okay, and chlorine with 4 as a substrate. And that one will be called carbon tetrachloride. Now take a look to these exercises, the rest. Tell me, do you want me to explain another one from here? From 1 to 10? From 3 to 10? Which one do you want me to explain?
Number 4.
Number 4.
Ah, it's true. No, I guess I know it. Okay, I will say it because I will explain what happened here. Covalent compounds are also known as molecular compounds. A molecule could be a gas, for example. Iodine gas is an example of a molecule. Iodine is a diatomic molecule. So iodine gas, because it's diatomic, will be just O2. Not O2, sorry, I2. There are a bunch of diatomic molecules. Actually, there are 7 diatomic molecules, but that is not your topic yet, okay? So this one was not part of the topic. I thought I had erased it, but I didn't. So, no, don't pay attention to that. From the rest of the exercise, do you want me to explain another one? Which one do you
Number
think is more
7.
complex?
The 7.
The 7. Okay, let's work with the 7. Okay, first of all, identify the elements. The elements are phosphorus and sulfide. Sulfide, okay, phosphorus, you know the element is P, phosphorus, okay? But sulfide refers to the element sulfur. Now, you have to take a look at the prefixes. Tetra means 4, and deca means 10, okay? Take a look. Deca means 10, and tetra, you know, it's 4. So the formula for this, it's going to be 4 phosphorus and 10 sulfurs. So the formula in the end will be phosphorus 4, sulfur 10. Like that. Okay. Did you understand this exercise, the number 7?
Means in number 6, it's only 1. It will be the fluoride.
It will be like the example of the iodine. This will be, this one I didn't see it, sorry. The iodine, I saw it, but I didn't erase it on time. But I knew that you were going to ask. But in the end, this one is the same example, so this will be fluorine gas. It's part of the diatomic molecules that I told you, but that is not part of the topic yet. Is that there are some molecules that cannot be alone. They need a partner, and those partners are known as diatomic. There are just 7 examples. You will have to memorize them, but That is later, okay? That is for the third partial, not yet. Is there another one you want me to discuss, or can I go to the next one, to the next topic?
Can you please do it with 10?
The number 10.
Yeah, number 10.
Okay, let me see. Okay, the number 10 says, okay, the number 10 says sulfur and fluorine. Here no suffix, okay? So it means excelente. Okay, it means no suffix, no prefix, sorry, and then the 6 refers to the prefix hexa, sorry. So how can we name this compound? Normally, when you don't have a subscript, we know it's 1, okay? And 1 can be replaced by the prefix mono. Then you write the name of the element. Then you write the other prefix that is hexa. And then the
Why did
result.
you write mono? It's not that when there's more
I'm
than one.
explaining. I'm not doing exercises. If you just want me to do exercises, I do them all, but that is not the purpose. I'm explaining from the beginning. Remember, this is a review. People who are people that are here, that is mandatory they to come. It is mandatory for them for a reason. Because they need a good score. And to get a good score, you need to understand the basis. I'm going there, okay? I'm going there. So I'm going to explain from the beginning. So because you don't have a subscript means 1. Sorry. And 1, as you can see, the prefix is mono. So you might be thinking that this is monosulfur hexafluoride. But the sad part of the story, remember the suffix IDE, okay? The sad part of the story is that this is one of the exceptions of the rules. Okay, it's not updating the whiteboard. Okay, that is one of the exception of the rule, because the rule says that for the first element is not necessary that you write the prefix mono, but it only works with the prefix mono. Okay, so if the first element has 1 as a subscript or invisible 1, you will never in your life write mono, only in the first element. So you get rid of it and just leave the sulfur. The sulfur goes alone in this exercise. Okay, my whiteboard is very slow. I'm going to change the app. Let me just take the exercises with me. So I have more examples here, 10 and 10. Now, take a look. Here I have, some of them are binary. The binary, I'm going to delete them. I'm going to delete the binary because I'm not going to ask you anything about binary compounds. Tomorrow I won't ask anything about binary compounds, ionic. Okay? So I'm going to delete those that we are not going to need for this class. And you might be wondering, so why you included them if you're not going to teach them? Because I already evaluated this topic. Okay, for example, manganese iodide, it's already evaluated. Potassium bromide is already evaluated. Lithium chloride is already evaluated. Which leaves us with the rest. So, tell me, what exercise do you want me to do?
The 7th one.
The 7. Do you want me to do another one?
The 5th one.
Do you want me to do another one?
The 9th.
Oh, the 9 is interesting. I like your choice. Okay, so what do we need for this topic? We need the famous tables that I gave you, okay?
Miss,
Yes, I will give you tables.
remember you say,
Yes,
all right,
I knew you were going
you
to say
forgot
that.
it.
I knew it. I totally knew it. Okay, I'm going to copy and paste it, well, the table that I think I'm going to use the most over here. I don't know if you can see the table. I'm going to try to make it bigger. Okay, I think that's nice. Wait a second. Okay. Yeah. There. Okay, you said the number 6. Take a look. First, all I do is I try to identify the polyatomic anion, which is always in the right side. Okay? So, what is the name of that polyatomic anion? Did you find it already? It's right here. It's called dichromate. Okay? So that one is chromium 2 dichromate. But I'm going to teach you how I decided to call it that way. As you can see, this table is showing you the charge of the polyatomic ion in the top. The charge is -2. If you still cannot see the charge, you can see the individual ion here. So the charge of dichromate is -2. In order to form this compound, you need chromium ion. I know, ¿qué hice? Wait. Wait a second, please. I need to delete all these. I'll be right there. I'll be right there with you. It's like it doesn't let me work because I need to lock that picture. That is something that I forgot from the beginning. And now you said that you need number 7, number 6, and number, I don't know. Which one was the other?
9.
Number
9
9.
was the other.
Okay. We said that we're not gonna do this because this is already evaluated. And the number 2. Okay. So, we identify dichromate as the polyatomic ion of this compound. Okay. So this is, that's interesting because you have chromium, and you have dichromate. So you have chromium together. That's nice. I like it. So take a look. Chromium, as you can see in your periodic table, chromium has multiple valence electrons. Okay? You can either have chromium 2, chromium 3, chromium
6.
chromium 6. What else? Just that?
Yes, only that.
Okay. And the polyatomic ion here, dichromate, why am I doing this? Why am I looking for all the possibilities? Remember that chromium has many possibilities. So I need to see what chromium is the one I'm using. In this case, I'm using chromium 2. Okay? Let's work with this one. What happens if I combine chromium 2 with the ion dichromate? What happened with the charges? Take a look to these charges. They are the same number, but they have different signs. The first one is positive and the other one is negative. When the two charges are the same but different symbol, they must be cancelled. So when this happens, you cancel the charges and the compound formed is CrCr2O7. Now tell me, is this compound the first compound that the problem gave us, the exact same, or is it different?
It's the same.
It's the same, okay? Because it is the same means that chromium 2 is the answer here, okay? So the purpose of this is that we have to name it. So the name for this compound will be chromium the charge that we used in the beginning. The charge is indicated here. No, ahí la borré, es que no es la otra app. The charge that I used in the beginning was 2, so I have to indicate the charge in Roman numerals. And then I write the name of the polyatomic ion. The name of the polyatomic ion, as you can see, is dichromate. That example is more complex because chromium has many possibilities. When an element has many possibilities, you have to write the charge in Roman numerals. But this works only for metals, ¿ok? El Roman numeral solo lo ponemos para metales. not for non-metals. Entonces aquí, remember this works only for metals. Now, the other two combinations, I don't need them. The reason is because my first guess was the right choice. So I didn't have to continue combining anything else because I already did it. I already got the right answer. But if in case it gives you a different formula, you have to continue trying. This is about trial and error too. Okay? You try. If it works, fine. If it doesn't, try again with a different charge. Now, the number 7 is also interesting because it's chromium, and chromium is polyatomic ion. Now, this one is a little bit easier than the one before. The reason is because of this charge right here. Remember that when you combine a compound, when you get compounds, you exchange the charges. So this 3 is coming from a place. This 3 is actually coming from chromium. Okay? So here is a little bit easier because the 3 indicates that the charge of the chromium is 3. So for this exercise, chromium is using 3 as a charge. Now, tell me, how do you call this polyatomic ion?
Fluoride.
Right.
Okay, take a look. We have hypochlorite, we have perchlorate, we have chlorate, and we have chloride. We have 4 possible combinations for chlorine and oxygen. So what we have to look at is at the amount of oxygens. Here, I have 2 oxygens, so I have to look at the one that has only 2 oxygens, which is
Fluoride.
chloride. Chloride. I-T-E, chloride. Okay? If you want to say it in Spanish, it's clorito. Okay? Clorato, clorito, hipoclorito, perclorato. In Spanish, 8 is ato and 8 is ito. Just for you to know. Exactly. The name will be chromium 3 chloride. For the person who sent it to me, that was perfect. Okay? So chromium 3, and the name of the ion, this one is chloride. So you have to write the number of the name of the ions. The cation, that is chromium. You have to indicate the charge, which is 3. Why is it 3? Because I can see the 3 right there. Okay, that's why it is 3. And then the name of the polyatomic, that is chloride. I know it's difficult. Sorry, I had a connection issue. Okay. So I was saying that I know that it's quite difficult when we have multiple charges, but you need to practice that. So keep your periodic table with you for you to recognize those elements that have more than one valence electron. If you are not sure, today practice and ask me. Practice this afternoon and ask me. Now, let's take a look at the last one, the number 9. I see copper and I see this substrate, okay? What does it tell me? That copper is using what charge?
Miss, you're not sharing screen.
Oh, really? I'm sorry. Yes, it's because of my connection. Hasta luego. Okay, the number 9. We have the copper and we have the 2 right here. That 2 as a substrate indicates the charge of copper, okay? Remember, because this 2 is coming from the metal, it's coming from the cation, okay? So this indicates that actually copper is using 2. Now, what is the name of this ion, of this polyatomic ion? Did you find it? Did you find it?
Hypophosphite?
It's not hypophosphite because it has 2 as a charge, okay? So if it's not the exact same, don't use it. So here it is not located, okay? So I'm gonna bring another table. Remember that in your quiz tomorrow is not going to be like that, okay? I'm going to give you only a table that you will need. So